Adam Savage here in my cave, and I've got a different kind of one-day build today. One that I haven't done as much on camera as I'm doing this build more on camera than I've done something like it before. Many of you followed along while I built a die filer last year. A die filer is a reciprocating machine that just moves the file up and down for doing sensitive work. I learned about them on ClickSpring and actually found the links to the die filer he uses through that. And it was a kit. It was a kit that came as a bunch of cast iron parts that I slowly machined over several months into a useful device. And that's what today's one-day build is also. Except instead of a moving machine, today I am building what's known as an instrument maker's vise. This is a picture of what the finished product should look like. An instrument maker's vise is not a musical instrument maker's vise, although I suppose the musical instrument maker could use it. It's specifically for machinists to hold work in complicated and precise ways. And when you buy one of these kits, this comes from Hemingway kits, and we'll include links to this kit in the comments below. Hemingway provides a set of full-size plans of all the pieces that you are making and their relative sizes to each other, which is really helpful, plus a breakdown of some of the major steps. There's the picture of the device, and they include some cast iron pieces to utilize and all the little bits of steel and metal and hardware that you will need to make the thing that they have sold you the kit for. Yeah. This seems like a perfect opportunity to increase my machine skills. I've just bought a new Kurt Vise for my mill, and I'm excited to fire it up. Okay, so today's one-day build. An instrument maker's vise. It is going to be dirty, dirty, dirty work because I'll be machining some cast iron, and there's no circumstance under which machining cast iron isn't filthy in the best way. All right, so within machining a piece like this vise, it stems off of this cast iron base, and this foot right here, this little foot, is actually just for grabbing in a vise like this, or my Wilton bullet vise over there. And to give you a better hold. So what's really important here is that these sides are roughly parallel, but there's no parallel and flat. And then they do, I mean, obviously I'd like to be parallel with the line that I'm drilling through this center hole. But first and foremost is to clean up the pieces of this cast iron on the bottom, sides, top, and the spindle hole there. I don't know if it's a spindle hole, just a hole. Right, okay, they're using a dovetail for that. Right, they've got a right angle milling attachment. Yeah, I'm going to start setting this up on the vise and start taking it down with some carbide bits. Right now, I am just going in here to flatten off this side. I'm going to turn it over, rest it on the parallels, flatten the other side, and then I will have some reasonable assurance that these two sides, this one, and this one, are parallel. Once I know they're parallel, I will grab onto them to do this part, and then once I know that's parallel, I'll grab onto it again and make these perfectly parallel. It's a little more work than I need to do for this, but you know what? It's just the right amount. I thought the camera was running, and it was not. And while I thought it was running, I made this little captured nut piece. I'm pleased with it. This is, you'll see where this goes. I made its mate, this piece here. It sits inside this reamed hole, and it's a nice fit. Actually, I'll show you. It's a very nice fit. That is within about 1.5 thou. I'm glad about that. Now I have to thread this. I actually have to add threads, and I'm going to do that using this guy. I am not going to cut threads. Nope. I'm going to use the die. So I guess that's what you're about to watch. Always a good idea to use your tailstock to set the flat and get it started. Oh, right. I'm also going to add some cutting fluid to this. And to here. Great. Oh, yeah. I want to lock that. There we go. Now, each time I'm turning it, I'm pushing the tailstock so that it meets it and helps it turn flat. I'm not using a standard 1/2" 13. I'm using actually a 1/2" 20 thread on this. The finer increment will give me more precise control. All right, let's see here how we're doing. So far, there we go. I know that all the books on tap say tap a full turn and go back a 1/2 turn. I have never found that to be the case. I have always found I had my best luck when I tapped a 1/2 turn and went back a 1/4 turn. I don't know whether they're working with bigger taps than I have or what, but all right, let's get that out of there and that out of there. Now we can, once I've got it going, I can kind of keep it going. All right, so here's what I have so far. I've got the main base very much cleaned up. Sides are parallel and square. I think I need to use a dovetail to knock out a little relief right there. This is bored out to 0.4999. This is machined to 0.4998, and it's nice and just no rattling. And then this is the capture nut. So what happens is that I'm going to clamp these guys in here. I got to drill a 1/2" hole through both this and this. And when I do and thread a 1/2" bolt through it, which is the main support for the vise, when I clamp it, basically turning the clamp here moves this piece that way and pressures this against the sides of the upright strut. So the next thing I need to do is the 1/2" hole through these. Doing an overhang here so you can see what I'm talking about. So I've got the, let's see here. Can you see them? Let's see. Get out of the way. Okay. Got my parts here. They're sitting in a V block, which means this is perfectly level, and I've checked it with my hammer gauge. I've also found the center, and I'm locked at the center here. And so now I'm going to use a center drill like this to mark this hole. I'm going to use the center drill to mark this hole, and then I'm going to slowly, successively go up to 1/2 inch, and that will complete the basic body of the clamp design of this machinist clamp. Thought the camera was rolling. I center drilled this hole, and then I drilled a 1/4 inch. Now I'm about to drill the 5/16 inch hole. Here we go. And collet. Now we put this in. All right. There's a reason we step up the drills rather than just drill one right through. And it took me a long time to kind of understand. When a drill bit is turning here, when a drill bit is turning, right, that's the chisel point. That right there, actually, let me clean that up. Well, you see the chisel point, you see that it's spinning, you see this little sharp edge here, which is going to peel up material, right? But now think about the fact that out here at the outer corner, that's spinning at the RPM of the mill. And so if I have it set at about 2400 RPM, that's moving at a certain speed. And close to the middle, it is also turning at 2400 RPM, but because it's such a smaller radius, the middle is turning way slower. So the middle of a twist drill has to do a lot more work to peel out. So what I do is, as I successively go up, I'm removing the middle, and I'm removing the part that's hard for a twist drill to remove. And that means that I'm inherently getting more accurate holes, because I'm doing most of the work out at the edge of this drill. Okay, here we go. Seven sixteenths, that's the next one. And these actually all mirror the sizes of the 5C collets I have. These are stepped up by 1/16 of an inch, so it works perfectly. Each time my drill bit gets longer, I have to... There we go. I'm going to use this very pretty unused drill. Oh, I don't think this has ever been, well, it might have been drilled with once, but yeah, it's a pretty one. Okay, so this is 31/32. Am I right about that? Oh. This is 31/64. So this is 1/64 under a 1/2 inch. Once I do this, then I'll ream this out and it'll be so exactly 1/2 inch. These are all very tight tolerances. I'm going to try spinning it half a rotation, see what I can get. I can loosen any of these tolerances I want later, but for right now, I just want to make sure that everything is really nice. Oh, I can feel what a bearing surface that is. That feels amazing. The thing is I don't machine stuff that's this precise. Yeah, it's just delightful. All right. This is the steel for the handle that goes here and the handle that closes the vise. So I'm going to want to, I can't even tell you how much fun it is to play. Each of these relationships is slightly less than 1/1000th of an inch, I believe. Maybe just about 1,000. So the way this works, just to make this crystal clear, is that this is a cap on this post. And when the two are joined together and a bar is put between them, and I tighten down on this one, this little inside lip means that this cap is now pushing upwards and pressuring this rod between the central rod and the cap rod. Yeah. And the way, yeah, isn't that neat? I think that's going to be really, really nice. And oh my God, I'm just really addicted to this, that feel, man. Maybe it's because, you know, this old Tony seems a little bit misanthropic and like nothing ever makes him super joyful. I mean, he gets happy, but like I kind of temper my expectations. But man, when you feel that, it's hard not to feel that life is good. Excuse me, I'm just going to spin my deal. Okay, handles. What do they have here? They have 1, 2, 3, 4, 5, 6, 12. They have 12 flutes. I guess I can cut these on a rotary table. Yeah, that's exactly what they have me doing. Okay, 1 3/4 OD, and this is currently 1 3/4 OD. Great, we're right there. I need to drill out the center of this. I need to face both sides. Then I'm going to drill all the way through. Then I think I'm actually going to tap. I think I'm going to tap now because it'll be easier to tap them when I can grab onto this big fatty than later when I can't grab onto it. Yeah, that's how we're going to do this. All right, I now have 2 handles that look beautiful from the front. They look beautiful, they look identical, their backs are a horror show. Yeah, I gotta clean up their backs. I gotta hold on to these. I have to hold on to these from both ends to do some finishing with them. And that's gonna require me to make a fixture. A fixture is, it's a separate machine part just to hold on to your machined parts. I'm going to make a cup fixture out of aluminum to hold on to these from the knurled side so I don't damage the knurled side. And then I'm just going to use my 2 J-collets to hold on to them from this side to do the last bit of cleanup up here. So let's see what I got. See, what I could do here is I could find a piece of nice round aluminum with a hole already in it, like this. That's actually a really nice chunk. I'm not throwing it. Oh, there's this. Suppose I could do that, seat it down in there, but that doesn't... I want to find the right amount of access to this part. It's almost like that could be it. This could be it, right? So all I need to do here is machine a little step in here that just fits this. Then slice this on the bandsaw and grab that with my 6-jaw, and that gives me a nice strong access to all of this material, to take out all of that material here. I think that's going to be my fixture. This right here, this is the tasty round aluminum chunk drawer. All right, I've turned the fixture. So you can see I have turned a little bit of a step here, and this fits really nicely in there. So I'll take this out, slice it on my bandsaw, and that should give me nice access to this backside to clean it up. Okay, look, here's the, nope, there it is. Here's my fixture. There's the piece I want to be fixturing. And this is a great, hold on. There's my fixture and there's my handle, and that's the god-awful side I have to clean up. Why is this better than the lathe chuck? The lathe chuck, one, grabs things so it can mar them. When I increase the surface area, that I am grabbing, I am reducing what can be marred because I'm spreading the load. And this is a great way to think about grabbing. How much can you grab? I'm grabbing as much as I possibly can. I'm grabbing this on 12 contact points all the way around this in the lathe vise. And I've got some real meat to crank down on this so that I don't have to, hopefully, worry about chatter over here. Just a little bit of grabbing philosophy, that's all. My handles are done. My hand wheels. I'm really, really happy with how they look. I see some tiny witness marks of the machining, but for the most part, they are observably identical. Oh, that is awesome. I just want to make sure that this is as smooth as it can be. This is my click spring shot. Oh. Feels good. Feels chocolatey. Oh, that's great. All right. That was one of the, yeah. Awesome. This is 1/2 inch. No, that's 3/7/5. So, because I had to drill the flutes in the handles in the clamp knobs, because I had to turn the flutes in the clamp knobs, these guys here, these guys, there we go. Because I had to turn those, well, I had the rotary table, which now I have to remove. So, excuse me. All right, gather around, y'all. This is one of the vise jaws, and I've just cut this beautiful little V-groove in it, and I think it's worth showing you how I cut it. Now, here is the mark for the horizontal V-groove, and I need to hold this in my mill at exactly a 45, so a nicely sharpened corner end mill, a carbide that I've got, will cut that V-groove. So I need to hold this in my vise. And to do that, I'm going to use a second smaller vise. I didn't make this. This is a little toolmaker's vise. And I think Right. So this is how I'm going to try and hold on to this like this. This has got a very positive grab system. So when you tighten it, it actually brings the jaw in. So it's a really, really great way to hold on to your work secondarily. So now I'm going to put this in the vise like this. Try and get that 45. Now my V-block, my issue is my V-block is wider than the piece I'm clamping. So I need some other mode. I was running into an issue where my V-block, which gives me a beautiful 45-degree mounting angle, is actually wider than this piece. So I can't use it to position my piece in the vise because the vise will clamp the V-block before it clamps my work. So I'm going to use this, which is another little toolmaker's vise I picked up a while back, and can give me the same exact deal, except at a smaller angle. Yeah, all right, so we're gonna get this one going. See if we can't get that. All right, 45, yeah, that's officially at a 45. Okay, so let's see if I can't. It's a very light cut I'm making, so I'm not that concerned with the torsion on the machine. It's best to mount everything in the middle. And yeah, okay, so it looks like I'm grabbing my vise, not the work, which is less than perfectly ideal, but it should be fine for this cut. Okay, I think I've got the line. I think I've got the level. I'm gonna lock my quill. I'm gonna back off my Y feed. And we're gonna try cutting this. All right, made the first little tiny cut, and it's a beautiful one. Yeah, so we're just gonna keep on creeping up on it. That's it. There we go. That is I think it's a respectable pair of V-grooves. They seem to meet at a nice little star there in the middle. Damn. Yeah. Okay, now it's time to drill those two holes. Okay, and that's the 5/16 pilot drill. I like not to move the XY when I'm in the middle of a critical position. It's superstitious, kind of, because you can move it and use your DRO to get you back, but there's too many things. Okay, there we go. Go. A 5/16 24 hole. Right? Right. 5/16 24. That's what this is. Hang on. Just matching up these. Yes, yes, yes. That looks great. All right. I'm going to use the old momentum of my quill technique for tapping. Let's get a little thread cutter in here. All right, I'm using a speed tap here. I'm using a what do you call it? A chisel point. Jesus, I lost the spiral point. I'm using a spiral point. So what I'm going to do is I'm going to spin this up. Then I'm going to turn it off, and as it's winding down, I'm going to feed it into the hole, and it's going to, and then eventually stop. But this tap is strong enough that it can take that. So I'm just going to put a little. Oh, the first taste of oil. All right, here we go. Up, down. Ooh, hey. All right. I had too much momentum there, but I think it still worked fine. Oh, shit. That was, hell's bells. That worked out just magnificently. Oh, that's not a 45, that's a 30. That don't look nice. Let's try it. Oh, that wasn't awesome. Okay, and we're just going to run this die all the way down. I'm keeping pressure on the chuck here to keep this flat. And then once I get it going, I'm pretty okay. I can check flatness, but it's really landing nicely. This feels weirdly too easy, but let me see if I can slow it down and. Yep. I have cut the jaw down on the bandsaw. There's a lot of moving parts to this, but hopefully this is one of my last cuts. I'm going to clean that up on the mill. This is just a test fit of all the pieces. This screws in there nicely. really close. Oh my God. I don't think I've ever worked on two separate things that were this close of a tolerance together. I'm going to have to rebuild half of these parts by the time I'm done, but hopefully not. Looks like I've messed up a critical relationship. But when I spin that, it should tell me, right? Let's get a... Whew! I really have it really doesn't work. Yeah, it looks like I'm wide by a few thousandths. So here's where we are with this guy. The individual relationships are correct. This threads in here nicely. That is awesome. It's when you bring in this with its parallelness. Right now we seem like we're okay, but I can see it right now. I can see. Again, I'm also working under, like, I can open up some of these measurements. I can make their relationships a little bit easier to get along. I already can't finish this today because I don't have a 1/2 inch, 20 threads per inch die. Yeah, I know I can cut it on the lathe. I don't want to cut it on the lathe today. Please don't make me cut threads. Please don't make me cut threads. I got nowhere else to go. Oh my God, these relationships are so freaking close. There's a whole nother day. I'm in the final mechanical stretch on my machinist toolmaker's vise. The vise itself, the action, is frankly better than anything I've ever gotten on a machine tool. This really looks like I knew what I was doing. It has increased. I did know what I was doing. It has increased my abilities. That's for sure. So I'm going to do a rough assembly, right? Yeah. I'm going to do a rough assembly. And then I'm going to do some final finishing on this guy. I might actually... I have this Wilton vise behind me that I think I'm going to do a restore on. And I think when I do that, I'm going to choose a color for the cast iron in my shop. I'm going to do the Wilton vise that color, this that color, and my die filer that color. So that'll be a separate video, but we are really close. Hang on. I think you want to see this a little closer. The way that feels, it's such a thing. So awesome. Ah, you have a little bit of a ding on you, don't you? Oh, we can't have that. Really, getting a through hole like this that works both ways, nearly impossible, but actually, I think I'll show it to you from the side. There we go. That's a little better. The thing I'm really happy with about this is that I actually thought I thought that these two rods were actually off by a small degree, but that would require me to remake this half, the movable jaw, the live jaw, but I didn't. This is a really, really awesome project, and these machinists' kits are super thrilling from a construction standpoint. Gosh, I just love this thing. It's so pretty. And I made it. Built this from scratch. That's, I mean, you know, a kit, but still, that feels like a real thing. There you have it. My machinist instrument maker's vise from Hemingway Tools, Hemingway Kits, is complete. First stage is complete. I am going to choose a paint color for this for when I restore my beautiful Wilton vise here, and I'll make those two the same color. But for right now, it's got some really nice action. It feels really good, and I feel like my machining skills have improved in the course of this project. I hope you feel the same way. Thank you guys so much for joining me for this one-day build. This has been really, really fun. And yeah, it totally took like 2.5 days. I will see you guys next time. Stay safe.